So I think we can probably start with the webinar. So welcome everybody who has joined. Probably see some people are still joining. So I'm just gonna kind of introduce what we're gonna talk about today. So basically, well, as you can see already from the title, we're basically gonna discuss our test range that we have made near our new office, where we have tested various geophysical sensors. So we'll also give you some information on this. So basically what sensors can be used, what's the data that you can get out of them, and also talk a bit about the test range itself and kind of what have we done there. The speaker for today will be my colleague Krišjānis, who is one of our engineers over here. Just like a few more remarks before we start. If you have any questions, please put them in Zoom. There is a Q&A section. So please put all of your questions in the Q&A so that we will either answer them in writing, or Krišjānis can also answer some of them live. And then at the end of the webinar, also, we can have a small Q&A where we can discuss any unanswered questions. So please do not use the chat for questions. Put all the questions that you have in the Q&A section. And also about the video recording. So the recording of this webinar will be published on our YouTube afterwards. So you will be able to go back and kind of revisit some parts. Also at the end, most likely I'll show this to you if we manage. But if you want to see more detailed information about all the sensors, then please go to our website, which is integrated.ugcs.com. So again, integrated.ugcs.com. I can also then maybe write it here in the chat for everybody. Then I think we can probably start. So Krišjānis, please, the floor is yours. So let's get started.
Hello, and welcome to another webinar of UgCS Integrated Systems by SPH Engineering. My name is Krišjānis, and I will be presenting our test range for drones with geophysical sensors. Today, I will briefly explain the reasoning behind our test range, describe the test range itself, show some data samples from the sensors we have already tested, and conclude with our offer for free and paid test range use. So almost any construction project requires excavation at some stage, thus introducing the risk of hitting existing underground utilities or unexpected objects. In most cases, available plans or drawings cannot exclude this risk because information is usually not full, precise, or up to date. Therefore, practice of using different kinds of sensors to gather actual data about underground utilities has become more and more popular. Different technologies are widely used for this, like EMI tools, GPR, cable locators, leak detectors, and others. In general, combinations of these tools allow for the location of almost any type of utilities and underground objects in the first few meters underground. However, when used from the surface, these devices can have limited productivity. Planning surveys and scanning of large areas can require significant time. So the idea of using unmanned aerial vehicles or drones to carry appropriate sensors to locate underground objects and utilities seems obvious. In fact, over 50% of requests about underground scanning we get are about utilities search. However, industry players lack strong experience and knowledge about the capabilities of airborne sensors or information about limitations of sensors combined with a drone. Another important point is the methodological aspects of airborne sensors application. How to plan UAV flights, data processing, expected precision of localization, and others. So SPH Engineering has built a test range with buried utilities, pipes of different diameter, material, and depth, as well as other objects, and conducted extensive tests of different available sensors over these known targets. Test results allow users to predict the probability of detection of a certain type of object using particular sensors, and also give recommendations about the applicability of them. Additionally, we have a considerable area for custom testing where targets can be placed for specific scenarios. So this is our test range. I will show you. So this is our office. Here we have the buried utilities, and the entire test range is this. It is located in Balozi, near Riga in Latvia. So it's 450 by 70 meters, and it is covered by a dedicated flight zone, so that you don't need to have special permits to fly there. And okay, so these are the targets we have buried, and they include metallic pipes here in blue, positions 1, 2, 4, 6, 15, and 17. And the red one is a stainless steel pipe. And also plastic pipes, either empty ones, 3, 5, or filled pipes, 14 and 16, which are filled with water. Also, there are different barrels in either horizontal or vertical position, and also one squished barrel. There are also two areas with uniform soil. One is the sandy soil area, and the other is a normal soil area where you can just bury something to look for it. The coordinates of each permanently installed target were fixed using RTK GPS with centimeter level precision. The distance from the top of the target to the surface was measured during the installation process. All pipes were laid out diagonally in the vertical orientation to test the response at different distances from sensors. Here you can see the pipes in the installation process, and what the pipes are, and here is the squished barrel. So for sensors without an internal data recorder, data was logged using SPH Engineering's UgCS Sky-Hub onboard computer. Also, as all the sensors are sensitive to the distance from the surface and targets, an active terrain following system with radar or laser altimeter was used to maintain constant drone altitude over the ground. The sensors were carried using a standard DJI EM600 Pro drone under the control of SPH Engineering's UgCS flight planning and control software. So the sensors we have tested include the time domain metal detector, Geonix EM61 Lite, several magnetometers, like Geometrics Magnar, senses Magnar III and 4, and also a custom sensor package designed by Johannes Bichtal. Also, we tested soil conductivity sensor, Geonix EM38 Mark II, and several ground-penetrating radars, among them Zone 12E 500 MHz shielded and 100 and 150 MHz unshielded antennas. So next, I will show you some data samples and explain how the tests were done. So this first one is the Geonix EM61 Lite, which is a lighter version of EM61 Mark IIA time domain metal detector. And it was designed for use on unmanned aerial vehicles. EM61 Lite has the same electronics console and coils as the original device. So expected results are the same as for EM61 Mark IIA. During experiments, we used 4-channel mode, and the distance from the lower coil and ground was 110 centimeters. Flight speed was 1 meter per second. All the metallic targets are visible in channels 1 and 2. In channels 3 and 4, thinner pipes disappear and data looks noisier. So as you can see, there was a higher background response of the sensor near the road, which is probably because of the reinforced concrete under the asphalt. Next one is Geometrics Magnar total field scalar magnetometer. And distance from the Magnar to the ground was 1 meter and flight speed 2 meters per second. All metallic targets except the thin steel pipe with a 1.5 millimeter wall were detected.
Christian, we have one question about the depth of the targets. Maybe you can quickly mention that.
Yeah, the targets are the depths of around 1.5 to 3 meters. So the pipes are laid down diagonally so that one end is higher and the other is lower. So you can get results from all this range of depths. Does that answer the question?
Yeah, I think that answers the question. Thank you.
Okay. So next we have two sensors, Magnar units. One is Magnar R III, which has two sensor, three-axis flux gates. And flight altitude for this, which is the distance from the sensor to the ground, was 1 meter, and flight speed 2 meters per second. Again, all metallic targets were detected except the small steel pipe here. Next, we have sensitive Magnar R4, which differs in that it has 5 sensors. And the results are exactly the same, except we get a denser data because we have 5 sensor lines for each flight line. We also invited Johannes Bistal to our test range. So he brought his own magnetometer units. We built the boom for them and did a survey with him. These magnetometers can be combined. So I think he has flown with up to 5 of these balls. Okay. Next, we have a Geonix EM38 Mark II, which is a soil conductivity sensor. It also produces interesting results on pipes, but well, it's not really suited for this particular task. And we also did flights with Zone 12E GPR. Here you can see the shielded antenna. And here is the new unshielded antenna. For those, we can produce data in geolytics and show the pipes themselves already, which is much different from the results you get from the magnetometer, because each pipe produces a nice parabola. So to conclude, all tested sensors demonstrated the ability to detect at least some targets. In general, experimental results were in line with expectations based on the nature of the sensors. And collected data makes it possible to predict the probability of detecting a particular target at a given depth. The test range is also available for custom projects. Like, for example, here, we used airplane engines in different orientations to determine the maximum altitude from which we can see them using a magnetometer. All manufacturers, colleagues, and scientific teams can use our test ground for experiments and testing. We can provide supplemental services like warm talks with our members and help if it's necessary, tea and coffee, workshop for fixing drones or tuning drones and sensors. Also drones to carry your sensors with our professional drone pilots, internet access, battery recharging, or whatever you need. All these services are available for free if this doesn't require too much time. And if we receive a full copy of the data collected over at our test range so that we can build a library of sensors and data, including raw, processed, and data interpretation. And we can announce the fact that these tests have been conducted, what data has been collected, and publish samples of data. Also, we can provide services as above on a paid basis, plus professional services for sensors integration, system tuning, consulting, and others. So this is the end of my presentation. So we can probably go on to the Q&A section, right, Kristaps?
Yeah, I think so. Maybe first, before we do that, yes, thank you, Christian, for your presentation and for Hope that everybody here kind of enjoyed it. And if you have some questions, yeah, please put them in the Q&A. Now I think what we can do, I can maybe show you guys our website, so you can also basically see different sensors that we're working with, because we also have data samples on our website that you can download and go through them yourselves. So maybe let me just quickly switch to that. Yep, there we go. So you should be able to see my browser screen now. So basically the site is integrated.ugcs.com. So basically here now I'm on the main site. Here you can also see different past webinars that we have done. And so now if we scroll down, you can see various different sensors that we are working with. So first you can see our bathymetric drone with the echo sounder sensor. Then also there's the GPR integrated system. Here you can see the M600 with the zoned 500 GPR. Yeah, by the way, I see your question, Martin. So yeah, Matrice 300 is supported by our sensors. So for the M300, we have GPR, we have echo sounder. So yeah, you can get in touch with us if you are looking for a solution for the M300. Yeah, so now if we go a bit lower, you can also see this is the Magnar magnetometer. This is the one we were also using in Greenland in 2019 expedition. Below this, you can see the Geonix EM61 Lite metal detector. So this one also Christian was showing the data results. Also now we have the Magnar III magnetometer, and also we are working with drone-based methane detectors. And yes, of course, one of the things about our systems is that for all of them, we have the SkyHub onboard computer, and we also have basically a radar altimeter that allows the drone to follow the terrain. So even though we have our test range, the terrain is quite flat, but then with this system, basically you can test the sensor, and then using the terrain following feature by using the altimeter, then essentially you can also use this on any terrain without the need to have a digital elevation model made for this terrain. Okay, so this is kind of regarding our sites. You can basically go through here. You can click learn more on any of these sensors, and so then you can see kind of a more detailed explanation in here. Many of you probably have questions. Yeah, so what's the maximum depth? When can you use these? So all of this information is available here on our website. And yeah, so you can kind of go through this. You can see what drones are supported. So currently we are supporting the DJI M300, M600, M600 Pro, including the RTK version, then also DJI M210 and M210 V2, as well as any custom-built drones based on either the DJI A3 autopilot or based on Pixhawk with Ardocopter firmware. So, and also, yeah, if you're interested in knowing more, learning more about our test range, then you can also kind of find this information here. You can also book the test range from our site. So yeah, you can also see, of course, the targets that were here, and these are kind of also the same images that Christianis now has in his presentation. But yeah, I think now, yeah, also some more information is available here on our YouTube channel, so UgCS TV. And also if you go to Facebook and search for SPH Engineering, then also you will find our Facebook page. And also we have our Facebook group that's called kind of UgCS users. So yeah, you can also go there and check it out. But right, I think now maybe it's time for us to go into the Q&A section. So please put all of your questions in the Q&A section. So we will try to either answer them live or to type in the answers for that. I see there's one, yeah, from Ronald about the airplane engines. So what's the maximum height of kind of at which you were able to get good data from that? Do you remember this, Christian? So at what altitude were we able to still see the airplane engines? I think it was something like.
I'm currently looking for it. It was different for Magnar and Magdrone. But I think we produced a white paper on that.
Yeah.
I don't seem to be able to find it. I will keep looking a bit. Okay.
Basically, over there we had like different airplane engines laid out with different weights, because we were well, our colleagues actually now have already headed out to an expedition, details of which hopefully you will find out somewhat soon. But yeah, so that's why we're just trying to estimate what airplane could we detect, because obviously the engine is the heaviest part of it. So as you know, in 2018, we did manage to find a lost World War II airplane in Greenland. So that's when, with GPR, with I believe it was Cobra SC-70 GPR, with that we're able to find the airplane engine at the depth of 100 meters below ice surface. So yeah, see, there's one question about drone shows, but I think you're in the wrong webinar for that. So yeah, if you're interested in drone shows, then please go to droneshowsoftware.com. That's our other product.
Yeah, but we use the same test range for drone shows as well.
Well, yeah, that's true. Okay, so let's see what other questions are there. Oh yeah, so from Eduardo, yeah, so you're asking about the is it possible to access the test data from the MAG sensors? I think it should be, yeah, it should be available. We can see. So this is still the test range. So I think let's maybe try the R3. Let's see if we have the data available here as well, because this might not be for all of them. Let's see. Yeah, I think here, yeah. So you see under laser altimeter for automatic terrain following, this is for the magnetometer drone in this kind of sub site of our website. So if you now click here on the data gathered from the same area using different flight altitudes, then this will basically take you to the download page. So over here, yeah, you can get the exported data from MagDrone, and plus additionally here you can, yeah, you can get these data files and also images. And I think there also should be a README with the explanation. So basically, you can see, let's say for the first flight, this was done with a side distance between survey lines of 1 meter, altitude was 1 meter in true terrain following mode, and velocity was 1 meter per second. So kind of through here, you should be able to see data. And I think for all sensors, we should have this data available on files.ugcs.com.
And if it isn't, you just can ask us to send you.
Yeah, exactly. So also you can go here to contacts, and yeah, so you can send either an email to UGCS or to our support, or simply kind of fill out the form here. So, you know, we're always available and always willing to help you out. Yeah, so this one I'll just mark as answered. So let's see what else is there. Oh, so there's one question here from David. So how much of an effect does a foliage or kind of plant material, or I suppose we can call it vegetation, how much does that have? How much of an impact does it have on the sensors? It depends on what sensors we're talking about. I'd say that on the, let's say something as like a magnetometer, it doesn't really have a huge impact. On something like a GPR, sometimes, yeah, it can maybe just cause some surface reflection, something like that. But yeah, for the most part, as long as you're flying quite close to the ground, then yeah, this should not really be an issue. One thing that obviously this will impact, so vegetation will impact the flight altitude at which you will be able to do your surveys. So you just have to kind of make sure that you are able to get the sensor as close as possible to the ground, because obviously, let's say if you're going to be flying, for example, you know, above the trees with the GPR, then of course you're not going to get any kind of good data. So the closer you are to the ground, the better. Vegetation can slightly affect the terrain following and kind of how that will work, because then of course the drone might go slightly up and also bring the sensor up with it. But yeah, other than that, it should not really be an issue.
But for terrain following, that really depends on density of vegetation.
Yep.
Because when we are looking for these burial sites with you, we were able to fly like 5 centimeters above the field because the altimeter was seeing the ground.
Yeah.
Yeah.
All right, so this one I'll also mark then as answered. Yeah, so another question is from Iole. I'm sorry if I'm mispronouncing your name. So is magnetic nuclear resonance carried by drone possible? To be honest, I haven't heard of anything like that. Maybe, I guess, well, it depends on, essentially you can put almost any sensor on the drone as long as, the drone can carry it if it's not too heavy. So we'd kind of need to look at some specific sensors that you would want to put on a drone, and you have to see whether we can put it there and whether we can integrate it. So yeah, if you have some specific sensor that you want to try, then yeah, please feel free to kind of send us a message, and then we can see what we can figure out.
One thing that we usually see, especially with magnetometers, is that drone noise is very uniform, and you can usually easily filter it, which reduces the overall sensitivity a bit, but produces really nice and usable data.
So we'll see what else is there. Maybe Krishan, you can answer this one if you understand. So can airborne sensors be ground balanced with high effectiveness to reduce the effect of noisy ground? I'm not sure if I understand the question fully.
I'm not sure I understand it either. You would probably need a geophysicist for it.
Yeah.
But for example, with magnetometers, we can and obviously have to adjust for local magnetic gradient, things like that, the same way as you do with a sensor on the ground. Team, can you maybe clarify did we answer the question or not?
Yeah, maybe you can write also in the Q&A. Was clear or not?
We are not really geophysicists. We fly drones, but we are learning.
And also, there's another question from Tim. So, can airborne sensors give a good indication of how ferrous a target is? Well, I suppose with metal detectors and magnetometers, I suppose that, yeah, but maybe Krishan, you can also
it's really sensor specific. For example, in our test results, we saw that this soil conductivity sensor detected ferrous objects really well, because they just made it go crazy because they're very conducting. So really depends on which sensor you use and at what altitude. But how ferrous, this will probably be best seen in comparison. So if you bury or just put on the ground pipes with different compositions, then you will be able to determine whether you can see this difference or not. I guess that is the best answer.
Yep. So another question is from Martin. So is there a specific sensor that can survey view through concrete or roads? So with this, I'd probably say, well, of course, it depends on what exactly you're looking for. But for this application, you can probably also look into GPRs, because one area where you can use ground penetrating radars is exactly that. So let's say if you need to see, for example, through asphalt or through something like that, and let's say, for example, for infrastructure detection, right? So then also for that, you can use GPRs, but it really depends on what are you looking for. If you're looking for some hollow kind of spaces, in the soil, then for that as well. But you kind of have to always look into the frequency of the antenna, and because different antenna frequencies will provide different resolutions for you. So you always kind of have to adjust it, or to basically just use the sensor that you need for the exact specific type of job. So, all right, I hope that answers that. A question from Patrick is, so have the sensors been tested on aircraft dropped ordnance? If I don't want to be mistaken, is this like kind of explosives that have been dropped, or am I wrong on this? I would probably need to search what exactly is aircraft. Okay, yeah. We haven't really tested the sensors or on something like that, but we have also basically kind of next to the test range that we have now, we have basically another like kind of smaller test range that was there, that was made a bit earlier. There, basically, we were testing detection of landmines with the GPR. So we can bury different objects in the diameter of 15 and 30 centimeters below the ground, and to see if it can detect it. So also we had plastic and metallic targets. So to answer your question, whether you can detect something like that, it really depends on what material is that and what size is that. So yeah, if you maybe have some specific some specific targets that you would be interested in looking for, yeah, then also we can maybe try to kind of somehow collaborate, because also this seems like quite an interesting project. So yeah, feel free to kind of drop us an email, and then yeah, we can talk further.
Okay, there is also a question from Jan. Does the SkyHub give access to all flight data from DJI and other drones? I think I can answer that. We collect data about flight parameters from the drone. So the tilt, the recorded altitude from the ground, speed, direction, things like that, GPS coordinates. But we don't record all the data from the drone. So if you really need a complete flight log, UgCS telemetry is recorded in UgCS, and drone-specific logs are on the drones themselves.
So thank you for answering that. Yeah, another question was from Tim. So to achieve the results that you showed here, so how far apart were the search rows? But I believe this was about 1 meter side distance, if I'm not mistaken, at least according to the data.
Well, it really depends on the sensor.
Yeah.
For example, Magnar III is not that wide. You have to use 1 meter. With Magnar R4 with a 2 meter boom, you can have a wider swath. But also depends on what resolution you really want, because all kinds of software can interpolate for you. So if you're not looking for small targets, then you might get away with like fewer lines. Also, when selling GPR, we have a special calculator that you can use to determine what distance do you need to do between lines to detect what kind of targets in what depth. So you can use that. And for example, with GPR, it really depends on the depth of the object, how deep it is. The closer to the ground it is, the closer you have to put your lines.
Yep. So I think that's probably mark then this as answered. Question from Lindsay is about anti-personnel mine detection and kind of what is the ideal sensor for that. I'd say it really depends on whether you're looking for modern landmines or kind of older ones, because older ones are more easily detectable, because especially if they're, let's say, the really old type where they're like round, you know, like about yay big, about 15 to 30 centimeters, and kind of made of metal, then they should be somewhat easy to detect. with the GPR and also, I believe, with the magnetometers. But so ideally, you would use probably a combination of sensors. However, if you're talking about some newer anti-personnel mines, they might be harder to detect, especially kind of quite small plastic ones. Yeah, you need to just specify a bit more what anti-personnel mines do you mean exactly, because there's quite a lot of them from different from different years.
Well, Lindsay is asking about anti-personnel mines, and I know for a fact that at least Census have conducted tests for different UXOs. I don't know if these test results are available on their site, but they were sharing a document with different sizes of bombs. And if you can't find it on Census site, we can send it to you.
So yep, this one then I'll also mark as answered. Yeah, I think we have now answered most of them. If maybe there's still some question that comes up that you feel we haven't yet fully answered, and please do not put links in the Q&A. So we'll not open your links right now. So yeah, so sorry about that. If you want to discuss some specific application, yeah, please do send us an email with that. Yeah, because just sorry, but during the webinar we don't really have time to read through the information that you provide in the links. Yeah, I think that probably now we have gone through the questions that we had. So yeah, unless something else comes up, then I think we can probably try to kind of wrap up this webinar. And like I said, we will provide the webinar recording. This will be on our YouTube channel, so UgCS TV. There you will be able to access it. So this is over here. Yeah, also, please make sure to check out our Facebook group. If you're using Facebook, also, we are active on LinkedIn. And yeah, so like I said, make sure to visit our website, so integrated.ugcs.com. And so then through here, you can go through all the sensors that we now discussed. You can also check out our test range and see different videos, webinars, and so on. But yeah, I think then that's probably it for today. So thank you everybody so much for joining. I hope hopefully you got some useful information out of this. And yeah, so to those of you with whom also we can talk through the Q&A, yeah, please make sure to also send us some emails. So yeah, we can stay in touch and maybe discuss you also coming to our test range so that we can try something out. But yeah, so all right, then thank you everybody. And yeah, I think then let's probably end it for today.
Okay, thank you everybody.
Yep, all right, bye.